Can you imagine a future where advanced materials like superconductors and nanomaterials are designed and developed by artificial intelligence? This isn't a futuristic dream or a plot from a sci-fi movie. The reality is that we're already witnessing this transformation unfold right in front of us. Welcome to the dynamic world where material science converges with artificial intelligence and machine learning. What was once a traditional field has now become a hotbed of innovation, driven by the integration of computational tools, AI, and machine learning. The transformation is not only reshaping industries, but also accelerating the discovery and development of advanced materials. Imagine the possibilities. We're not just talking about creating new materials, we're talking about revolutionizing the way they're made. AI and machine learning are enabling precision and volume in material production that was previously unimaginable. From smart packaging to lightweight materials for vehicles, the applications are as diverse as they are groundbreaking. Equipment durability takes on a new meaning when AI is at the helm, and renewable energy technologies are reaching new heights of efficiency. But this isn't a transition that's happening in a vacuum. It requires foundational education in AI, robust data management, and a strong commitment to AI ethics. Cross-disciplinary collaborations and pilot projects are paving the way for this new era of material science. Companies are embracing these technologies not just to stay competitive, but to be environmentally conscious in a rapidly evolving business landscape. The integration of AI and machine learning in material science is more than just a trend. It's a game changer. No longer a mere fantasy, this is the present reality of material science, thanks to the integration of AI and machine learning. But the influence of AI and machine learning extends far beyond material design and discovery. No industry is left untouched by the transformative power of artificial intelligence and machine learning, and the manufacturing sector is no exception. These technologies are revolutionizing how we produce materials, bringing unprecedented levels of precision and scale to the table. Imagine a world where smart packaging is no longer a dream but a reality. AI and ML are making this possible by enabling intelligent systems that adapt to various environmental conditions, ensuring the safety and durability of products during transit. But it doesn't stop there. These technologies are also leading the charge towards the development of lightweight materials. In the automotive industry, for instance, the use of such materials can significantly reduce the weight of vehicles, resulting in improved fuel efficiency and a reduction in greenhouse gas emissions. Equipment durability is another area where AI and ML are making a significant impact. By leveraging predictive maintenance models, manufacturers can foresee potential equipment failures and carry out preventive measures, thus extending the lifespan of their machinery and saving costs in the long run. And let's not forget about renewable energy technologies. AI and ML are instrumental in optimizing the design and production of materials for renewable energy technologies, thus paving the way for a more sustainable future. With AI and machine learning, the manufacturing landscape is undergoing a paradigm shift. The future is here, and it's powered by artificial intelligence and machine learning. From smart packaging to lightweight materials, equipment durability, and renewable energy technologies, there's no denying that these technologies are redefining the manufacturing processes as we know them. So, what does it take to succeed in this new era of material science? Firstly, one cannot underestimate the importance of a solid foundational education in artificial intelligence. It's the springboard from which all other advancements are launched. But it's not just about understanding the technology. It's about knowing how to apply it in innovative and groundbreaking ways. Collaboration is key in this new era. We're talking about cross-disciplinary collaborations, scientists, engineers, technologists, and industry experts, all working together, pooling their expertise to drive innovation on a scale we've never seen before. Next, we have pilot projects. These are the testing grounds for emerging technologies, the places where theories and concepts are put through their paces, where success is measured and improvements are made. Robust data management is another essential component. With the sheer volume of data that AI and machine learning generate, having a system in place to manage, analyze, and interpret this data is crucial. And let's not forget about ethics. As we push the boundaries of what's possible with AI, we must also consider the ethical implications. We need to ensure that these technologies are used responsibly and that they contribute positively to society. Finally, for companies hoping to remain competitive in this fast-paced, rapidly evolving landscape, embracing these technologies is not just beneficial, it's essential. It's also a way to stay environmentally conscious. using smarter, more efficient materials and processes to reduce our impact on the planet. As we look to the future, one thing is clear. AI and machine learning are not just shaping the future of material science, they are redefining it.